Deep beneath the surface of our world, where sunlight has never touched stone and where the air grows thick with the weight of ages, there exist places that humanity has carved from the living rock, chambers and corridors that wind through darkness like the veins of some ancient sleeping giant. And it is in these forgotten depths that our story takes place, a tale of ambition and discovery, of knowledge pursued at the edges of what was known and what was forbidden. A story about a man who sought to transform not just base metals into precious ones, but to transform his very understanding of the natural world itself. This is the account of an alchemist, a practitioner of the proto-sciences, who descended into the mountains, embrace seeking answers to questions that had haunted scholars and seekers for generations. Questions about the fundamental nature of matter, about transformation and permanence, about whether the secrets of creation itself could be unlocked through careful observation, precise measurement, and unwavering dedication to the pursuit of truth. The mountain that features in our narrative is not merely a geological formation, not simply an arrangement of stone and mineral laid down over countless millennia, but rather a character in its own right, a presence that shapes events as surely as any human actor. For mountains are repositories of deep time, places where the Earth's history is written in layers of sediment and stone, where pressures and temperatures beyond human experience have worked their slow magic. Creating within the rock itself, a kind of natural laboratory, where elements combine and recombine according to laws that the alchemist sought to comprehend and perhaps to master. To understand our alchemist and his journey into the mountain's depths, we must first understand the world from which he came, an age when the boundaries between what we now call chemistry and what was then called alchemy remained blurred and indistinct, when the transformation of materials was understood not merely as a physical process, but as something deeper, more profound, a participation in the fundamental creative forces of nature itself. The alchemists of this era were not the charlatans and frauds that later ages would sometimes paint them as, though certainly such deceivers existed among their number, but rather serious investigators of natural phenomena, individuals who established laboratories and conducted experiments, who kept detailed records and corresponded with fellow practitioners across vast distances, sharing observations and techniques. Building slowly and methodically toward a comprehensive understanding of material transformation. They worked with furnaces and retorts, with alembics and crucibles, subjecting substances to heat and cold, to dissolution and crystallization, observing carefully what occurred when different materials were combined, when they were heated to specific temperatures, when they were exposed to various conditions and influences. The alchemical worldview held that all matter was fundamentally connected, that the same principles governed the formation of metals in the earth and the growth of plants in the soil, that understanding these principles would grant not just the ability to transmute one metal into another, but deeper insights into the workings of nature itself, insights that could lead to the creation of medicines, the extension of life, the perfection of imperfect substances, and perhaps ultimately to wisdom itself. That most sought after and elusive of goals. Our alchemist, whom we shall call simply the practitioner, for his true name has been lost to the passages of time and the discretion he maintained during his lifetime, had devoted decades to the study of transformation, beginning his studies in youth and continuing them through middle age and into the later years of his life, accumulating knowledge from ancient texts and contemporary correspondence, from his own experiments and the reported experiences of others. He had studied the behavior of metals under heat, the way certain substances would dissolve in particular solutions while remaining unaffected by others, the curious properties of materials like sulfur and mercury, quicksilver that flows like water but possesses the luster of silver, sulfur that burns with an acrid flame and leaves behind residues of unexpected colors and properties. He had learned to recognize the signs of chemical change, the way colors shifted during heating, the way precipitates formed when solutions were mixed, the way certain reactions proceeded slowly while others occurred with explosive violence. He understood, as much as anyone in his era could understand, that matter was not immutable, that substances could be broken down and recombined, that what appeared solid and permanent could be transformed under the right conditions. Yet for all his learning and experience, for all the years spent in his laboratory conducting experiments and recording observations, he felt that something essential remained beyond his grasp, some fundamental principle that would tie together all his scattered observations and partial understandings into a coherent whole. It was this hunger for deeper understanding that eventually led the practitioner to the mountain, drawn by stories and rumors that had circulated among alchemists for generations, tales of extraordinary mineral deposits found in certain deep caves, of unusual formations that seemed to defy conventional explanation, of places where the Earth's creative forces remained unusually active and accessible to investigation. The specific mountain in our story had been known to contain extensive cave systems for centuries, but only recently had explorers begun to map these underground passages in any systematic way, discovering chambers of remarkable size and beauty, passages that descended to extraordinary depths, and most intriguingly for our purposes, mineral deposits of unusual character and composition. The practitioner had obtained reports from mineralogists and explorers describing formations unlike anything found near the surface, crystals of unusual size and clarity, metallic ores of remarkable purity, and strange admixtures of substances that, according to conventional understanding, should not occur together naturally. These reports fascinated him, for they suggested that deep within the mountain, conditions existed that might provide clues to the fundamental processes of material transformation, that by studying how nature herself combined and transformed substances under the unique conditions found in these depths, he might gain insights that no amount of laboratory work could provide. The decision to undertake such an expedition was not made lightly, for the practitioner was no longer a young man, and the physical demands of descending into deep caves were considerable, requiring strength, endurance, and a tolerance for confined spaces and absolute darkness that not everyone possessed. Moreover, the endeavor would require significant resources, equipment for descending into the depths safely, provisions for an extended underground stay, instruments and materials for conducting observations and collecting specimens, and reliable assistance from individuals experienced in underground exploration. The practitioner spent months in preparation, consulting with cave explorers about the techniques and equipment necessary for safe descent and ascent, studying maps and descriptions of the cave system to identify the most promising locations for investigation, assembling the tools and materials he would need, and most importantly, finding and training assistants who could help him in his work while maintaining the discretion he deemed essential. For he had no wish to attract unwanted attention or competition that might interfere with his investigations. The day chosen for the descent arrived in early autumn, when weather conditions were most stable and the likelihood of flooding in the cave system was lowest, and as dawn broke over the mountain's peak, the practitioner and his 3 assistants began their journey, not climbing upward toward the summit as travelers usually did, but making their way to a particular location on the mountain's flank, where a large opening descended into darkness. The primary entrance to the cave system that would be their destination and their workplace for the weeks to come. The mouth of the cave was impressive in its dimensions, large enough that a person could walk upright without difficulty, and as they paused at the threshold between sunlight and shadow, the practitioner felt a mixture of anticipation and trepidation, for he was about to leave behind the familiar world of surface and sky, of natural light and open spaces, and enter a realm where darkness was absolute, where no living thing grew, where the only sounds would be those they made themselves, and the occasional drip of water or fall of stone, a realm that operated according to its own rules and rhythms, shaped by forces that worked over timescales that made human lifetimes seem like the briefest of moments. The initial descent was gradual, the passage sloping downward at an angle that allowed them to walk rather than climb, though the footing was uneven and required careful attention, for the stone was often slick with moisture and littered with loose rocks that could turn an ankle or worse. They carried lamps, simple all-burning devices that cast pools of warm yellow light, pushing back the darkness immediately around them but seeming to make the surrounding blackness even more profound by contrast. And as they moved deeper into the mountain, the temperature began to change, the outside air's warmth giving way to a coolness that penetrated their clothing and made them grateful for the heavy garments they had worn despite the mild surface temperature. The cave's character changed as they descended, the initial single passage branching into multiple corridors, some continuing downward while others led off horizontally or even climbed slightly before descending again, a 3-dimensional maze that would have been hopelessly confusing without the maps they carried and the markers they placed at each junction to ensure they could find their way back to the surface. The walls of these passages bore the marks of water's patient work, smooth surfaces carved by ancient flows, rippled textures where mineral-laden water had deposited successive layers of calcium carbonate, occasional pockets where crystals had formed in sheltered spaces, glinting in the lamplight like scattered jewels. After several hours of careful progress, stopping frequently to consult their maps and place markers, they reached the first of the major chambers they had planned to investigate, a vast open space that their lamplight could not fully illuminate, though glimpses of distant walls and ceilings suggested dimensions that would have been impressive even in a building constructed on the surface. The floor of this chamber was relatively level, covered in places with fine sand and silt deposited by long-ago flooding, and toward the center, a pool of perfectly still water reflected their lights like a mirror of obsidian, its surface so calm and undisturbed that it was difficult to judge its size or depth. This chamber would serve as their base of operations, a place to store supplies and equipment, to rest between expeditions to other parts of the cave system, and to conduct initial examinations of the specimens they collected, and so they set about establishing their camp, unpacking the provisions they had carried, setting up a more substantial lighting system using multiple lamps placed strategically around their work area, arranging their tools and instruments in an orderly fashion that would allow efficient work despite the challenging conditions. With their base established, the practitioner began to implement the procedures he had planned during his months of preparation, transforming this natural chamber deep within the mountain into something approximating a laboratory, though one unlike any that had existed on the surface. For here he had access not just to the materials and equipment he had brought with him, but to the mountain itself, to mineral deposits that had formed under extraordinary conditions, to rock formations that represented millions of years of geological processes, to waters that had dissolved and carried minerals from deep within the earth, concentrating certain elements and compounds in ways that rarely occurred near the surface. He established a work area where specimens could be examined and prepared, setting up a small furnace that could be used for heating samples, arranging his collection of vials and containers for storing different substances, positioning his scales and measuring instruments where they would be protected from moisture and accidental damage. His assistants, who had been chosen not just for their physical capability, but for their intelligence and willingness to learn, were instructed in the careful procedures required for collecting specimens, taught to recognize different types of mineral deposits and rock formations, shown how to use the tools for extracting samples without contaminating them or damaging the formations from which they came, trained in the methods of labeling and cataloging that would ensure nothing was confused or lost in the darkness and complexity of the underground environment. The practitioner's methodology was systematic and thorough, for he understood that the value of his investigation would depend not on chance discoveries or lucky finds, but on careful observation and precise record-keeping, on building up a comprehensive collection of data that could be analyzed and interpreted to reveal underlying patterns and principles. Each day, or what they designated as day in the timeless darkness of the caves, was devoted to a specific aspect of the investigation, with some periods spent exploring new areas of the cave system, mapping passages and identifying mineral deposits of potential interest, other times dedicated to collecting specimens according to predetermined criteria, carefully extracting samples and documenting exactly where and under what conditions each had been found. And still other periods focused on examination and initial analysis, studying the physical properties of collected materials, testing their behavior under different conditions, comparing them to substances familiar from surface investigations, and noting similarities and differences. The practitioner kept detailed journals, writing by lamplight in careful script, describing everything he observed, recording measurements and observations, noting questions that arose and hypotheses that might explain the phenomena he encountered, building slowly and methodically toward a comprehensive understanding of the mountain's underground realm and the transformative processes that operated within it. As days turned to weeks and the investigation progressed, the practitioner began to make observations that both confirmed his theoretical expectations and surprised him with unexpected findings, for the deep cave environment proved to be even more complex and interesting than he had anticipated. In certain chambers, he found mineral deposits of extraordinary purity, veins of metallic ores virtually free of the impurities that typically complicated extraction and refinement, suggesting that the conditions under which these deposits formed had been remarkably stable and conducive to the selective concentration of specific elements. In other locations, he discovered the opposite, complex admixtures of different minerals, intimately combined in ways that would be difficult to achieve even through careful laboratory procedures, indicating that under certain conditions, the Earth's processes could produce combinations and associations of materials that seemed almost deliberately constructed. He found crystals of remarkable size and perfection, geometric forms that grew with mathematical precision from the surrounding matrix, their faces flat and angles exact, demonstrating that even in total darkness, without any external guidance or intervention, matter could organize itself into structures of astonishing order and beauty. One discovery that particularly fascinated the practitioner was a series of small pools in a remote chamber, pools that, unlike the large still water in their base chamber, were not stagnant but fed by slow seepage from the surrounding rock, water that had percolated through the mountain over centuries or millennia, dissolving minerals as it traveled, becoming saturated with various substances, and then in these pools, depositing those dissolved materials in new forms as conditions changed and chemical equilibria shifted. The practitioner collected samples of these mineral-rich waters, carefully sealing them in glass vials for later analysis, But more than that, he observed the pools themselves, noting how different minerals precipitated in different locations within the same pool, how some substances formed crystalline deposits while others created powdery precipitates or gelatinous masses, how the rate of deposition seemed to vary with subtle changes in temperature or the rate of water flow. These pools, he realized, were natural laboratories where transformation occurred continuously, where the processes he attempted to induce and control in his surface laboratory happened spontaneously, guided only by the inherent properties of the materials involved and the conditions that existed in these hidden depths. Another significant finding emerged from his investigation of the cave's different levels, for the system extended through hundreds of vertical feet, and the practitioner discovered that conditions varied systematically with depth, with temperature rising slightly in the deepest accessible chambers, with humidity patterns that changed depending on elevation and proximity to water sources, with mineral compositions that reflected the different rock strata through which the cave passages wound. This vertical structure, he realized, meant that the mountain contained within itself a range of different environments, each potentially favoring different types of mineral formation and transformation, and by studying specimens from different depths and locations, he could begin to understand how changes in temperature, pressure, and chemical environment affected the processes he sought to comprehend. He theorized that by understanding these relationships, by determining which conditions favored which types of transformation, he might be able to optimize his own laboratory procedures, deliberately creating conditions that matched those found in the most productive natural environments within the mountain. As his investigation continued, and his collection of specimens and observations grew, the practitioner became aware of a pattern that both intrigued and puzzled him, for among all the mineral deposits and formations he had studied, there was one type that seemed particularly unusual: samples that contained a combination of elements and exhibited properties that did not fit neatly into his existing framework of understanding. These specimens came primarily from the deepest chambers they had accessed, areas where the rock was older and had been subjected to greater pressures and temperatures over geological time, and they displayed a metallic luster, but were neither pure metals nor simple alloys of familiar types. When heated in his small underground furnace, they behaved in unexpected ways, releasing vapors of unusual colors, leaving residues that changed appearance as they cooled, producing effects that reminded him of reactions he had observed in his surface laboratory, but also differed in subtle but significant ways. He collected as many samples of this material as he could find, carefully documenting each location and the circumstances of discovery, but the more he studied them, the more convinced he became that understanding these unusual specimens required going deeper still, descending to levels of the cave system that his initial maps suggested existed, but which had not yet been thoroughly explored. The decision to press deeper into the mountain was not without risk, for the passages that led to the lowest levels were more challenging, involving sections where proper climbing would be necessary, where the routes were less certain and the possibility of becoming lost or trapped more significant. Moreover, the supplies they had brought were not unlimited, and extending their investigation meant carefully calculating how much longer they could remain underground before the need to return to the surface became pressing. The practitioner consulted with his assistants, explaining what he hoped to find and what the risks would be, and to his gratification, all three expressed willingness to continue, for the two had been caught up in the fascination of discovery, had seen enough to understand that something genuinely significant was being revealed through their work, and were willing to push forward despite the challenges and uncertainties. They spent a day reorganizing their supplies, identifying what was essential and what could be left behind if necessary, preparing the specialized equipment needed for descending vertical shafts and negotiating difficult passages, and reviewing the maps and explorer accounts that described the deepest known chambers and the routes to reach them. The descent to the cave system's deepest levels began in the early hours of what they calculated as morning, though in the perpetual darkness of the underground realm, such designations were purely conventional, markers they used to maintain some sense of structure and routine, rather than surrendering completely to the timeless nature of their environment. The route they followed took them through familiar territory initially, retracing passages they had traversed many times, but eventually led them to a junction where they would take a path previously unexplored, a narrow corridor that descended at a steep angle, requiring them to move carefully, bracing themselves against the walls, testing each foothold before committing their weight. The rock in this passage was different from what they had encountered in the upper levels, darker and denser, with a fine-grained texture that suggested it had been subjected to extreme pressures, metamorphosed from whatever it had originally been into something harder and more compact, and the practitioner noted this observation in his journal, recognizing it as evidence that they were indeed penetrating to levels where the mountain's deep structure was being revealed. After what seemed like hours of careful descent, the narrow passage opened suddenly into a vertical shaft, a cylindrical void that disappeared both upward and downward beyond the reach of their lamplight, and here they would need to use ropes and climbing techniques to continue, for there was no natural path down, only the smooth walls of the shaft, carved by ancient water flows that must have been far more powerful than the slow seepage that currently characterized the cave's hydrology. They secured their ropes to stable anchor points, tested them thoroughly to ensure they would bear the necessary weight, and one by one lowered themselves into the shaft, descending hand over hand through darkness that seemed to have physical presence, pressing in around them despite the lights they carried. The descent through the shaft was both physically demanding and mentally taxing, for there was no reference point except the rope itself, no way to judge how far they had come or how much further they needed to go until finally, unexpectedly, the first to descend called up that he had reached the bottom, had found solid footing and a continuation of the cave system, and the others followed with renewed energy, knowing that their goal was close at hand. The chamber they entered after emerging from the shaft was different from anything they had encountered before, smaller than the vast spaces of the upper levels, but possessing a quality that was difficult to define, a sense of age and isolation, as if this place had remained undisturbed for periods of time beyond human comprehension, sealed off from the surface world by hundreds of feet of solid rock. Connected to the upper caves only by the narrow shaft they had just descended, and perhaps by other passages long since blocked by rockfalls or sealed by mineral deposits. The air here was noticeably warmer, a phenomenon the practitioner attributed to their proximity to the Earth's deep heat, that gradient of increasing temperature that explorers and miners had documented descending into the Earth, evidence of the tremendous energies contained within the planet's interior, energies that drove volcanic eruptions and earthquakes on the surface, but which here in the deep stability of the mountain's core manifested only as this gentle warmth, and perhaps as a catalyst for the geological processes that had formed the unusual minerals he sought to study. As they explored this deepest chamber, methodically examining its walls and floor, documenting its dimensions and characteristics, the practitioner found what he had hoped to discover: mineral deposits that clearly represented the same unusual material he had found in smaller quantities at higher levels, but here occurring in greater abundance, and in formations that suggested active ongoing processes rather than ancient deposits laid down long ago and simply preserved. The walls in one section of the chamber were covered with crystalline growths, delicate structures that seemed almost fragile but which examination revealed to be quite hard and resilient. And these crystals possessed a peculiar property, for when illuminated by the oil lamps, they seemed to capture and hold the light, glowing faintly even after the direct illumination was removed, as if they had absorbed some portion of the light's energy and were releasing it slowly back into the surrounding darkness. The practitioner had heard of materials that possessed such properties, minerals that would glow after exposure to sunlight or other strong illumination, but he had never encountered the phenomenon in such pronounced form, and he recognized that this property alone suggested something unusual about the crystal structure or chemical composition of this material. More interesting still were the deposits found near what appeared to be a spring, a place where water seeped from a crack in the chamber's floor, forming a small pool no larger than a person's hand, a pool that was slowly depositing minerals around its edges, building up layers of material in concentric rings like the growth rings of a tree, each layer slightly different in color or texture from those above and below. A record written in stone of changing conditions and varying compositions in the water that fed the spring. The practitioner carefully collected samples from different layers of this deposit, scraping away tiny amounts of material with tools designed for precision work, sealing each sample separately and labeling it with meticulous attention to detail, for he understood that these layers might tell a story, might reveal how conditions had changed over time, might provide insights into the processes that concentrated and deposited the unusual elements and compounds he had found. He also collected samples of the water itself, though it was emerging so slowly that filling even small vials required patience. And he noted that the water had a slightly bitter taste and left a faint metallic residue on the lips, suggesting it was indeed heavily laden with dissolved minerals, saturated with materials leached from the surrounding rock during its long journey through the mountain's interior. The practitioner spent several days in this deepest chamber, longer than he had planned, for the place proved to be far richer in interesting phenomena than he had anticipated, and despite the physical discomfort of the environment, the constant dampness and the mental strain of working in absolute darkness, relieved only by their lamp's small pools of light, he felt that he was finally approaching the understanding he had sought, that the pieces of the puzzle were beginning to fall into place. That patterns were emerging from his accumulated observations. He conducted experiments in this natural laboratory, taking advantage of the unique conditions that existed here: the slightly elevated temperature and high humidity, the proximity to active mineral deposition, the presence of water saturated with dissolved materials. And he made observations that he knew would take months or years to fully analyze and interpret, but which already suggested that his theoretical framework for understanding material transformation was broadly correct, while also needing refinement and expansion in light of what the mountain had revealed. One evening, or what they designated as evening in their maintained routine, as the practitioner sat by lamplight reviewing his notes and observations, organizing his thoughts and attempting to synthesize the vast amount of information he had gathered, a moment of clarity came to him, one of those rare instances when disparate observations suddenly coalesce into a unified understanding. When the pattern that had been present all along, but obscured by incomplete information, becomes suddenly visible and obvious. He realized that what he had been observing in the mountain's depths was not simply the passive accumulation of minerals, not merely the slow deposition of dissolved materials as conditions changed, but rather an active process of transformation driven by the inherent properties of matter itself, operating under specific environmental conditions, a process that in its essential nature was no different from the transformations he attempted to induce in his surface laboratory, but which here proceeded according to nature's own schedule and pathway, guided by conditions that had remained stable for geological ages, producing results that demonstrated what was possible when transformative processes operated without interference or artificial constraint. The unusual minerals that had particularly interested him, he now understood, were not fundamentally different from more common substances, but rather represented states of combination and organization that occurred only under the specific conditions found in the mountain's depths, conditions of temperature and pressure and chemical environment that could potentially be reproduced in a laboratory if one understood what those conditions were and how to create them. And this realization was significant because it suggested that the boundary between what occurred naturally and what could be achieved through human art was not fixed and absolute, but rather permeable and negotiable, that understanding natural processes deeply enough meant gaining the ability to work with those processes, to guide and direct them rather than simply observing them from outside. This was not the crude ambition of turning lead into gold through some mystical process, but rather the more profound and achievable goal of understanding transformation at a fundamental level, of recognizing that different substances were not entirely separate and distinct, but rather represented different states or arrangements of common underlying components, and that changing those arrangements, reorganizing those components according to natural laws that could be discovered and applied, was the true meaning of alchemical transformation. The practitioner also understood something else, something perhaps even more significant for the future development of natural philosophy and what would eventually become chemistry, and that was the critical importance of conditions and environment in determining how substances behaved and how transformations proceeded, for he had seen in the mountain's vertical structure how the same basic materials produced different results at different depths. How temperature and pressure, and the presence or absence of water or other substances, could shift chemical equilibria, favor one type of reaction over another, determine whether substance would form crystals or precipitate as a powder, whether it would remain stable or undergo further transformation. This understanding implied that the alchemist's art was not about discovering a single universal method or substance that could transform anything into anything else, but rather about developing a comprehensive knowledge of conditions and their effects, about learning to create and maintain the specific environments in which desired transformations could occur, about working with natural processes rather than attempting to override or replace them. Eventually, though the practitioner would have preferred to remain longer, to continue his investigations and observations, practical considerations demanded that they begin the return to the surface, for their supplies were depleting, their lamps were consuming the last of their oil, and they had been underground for longer than originally planned, long enough that those who knew of their expedition might begin to worry, might even organize search parties that could complicate their return. The practitioner spent a final day in the deepest chamber, making last observations and collecting final specimens, paying particular attention to the spring and its mineral deposits, for he believed this location represented the heart of what the mountain had to teach him, and then, with some reluctance, he gave the order to prepare for ascent. They packed their equipment and specimens carefully, organizing everything to ensure nothing would be lost or damaged during the difficult climb ahead, and they reviewed their route, checking that they still had adequate markers to guide them back through the maze of passages they had navigated on the way down, confirming that their ropes and climbing gear were in good condition for the ascent through the vertical shaft. The journey back was, in some ways, more challenging than the descent, for they were tired from their weeks underground, their muscles fatigued from the constant physical demands of working in the cave environment, and climbing upward required more effort than descending had, fighting against gravity rather than working with it, and carrying specimens and equipment added weight and awkwardness to an already difficult ascent. Yet they persevered, drawing on reserves of determination and the satisfaction of knowing that their expedition had been successful, that they were carrying back not just specimens but understanding, not just observations, but insights that would advance the alchemical art and contribute to humanity's growing knowledge of the natural world. The climb through the vertical shaft was particularly arduous, requiring them to haul themselves up the rope hand over hand, their arms burning with effort, their hands cramped from gripping the rough rope fibers. But eventually, all four emerged at the shaft's top, returning to the passages they had descended days before, and from there the route was familiar if still demanding, leading steadily upward through the mountain's interior. As they climbed, the practitioner found his thoughts turning not to the surface world they were returning to, but to the deeper meanings of what they had discovered, to the implications of his observations for understanding the natural world and humanity's place within it, for he had spent weeks in an environment utterly unlike the surface realm, a place where no living thing could survive. Where darkness was absolute, and water moved through stone over timescales that made human lives seem ephemeral as mayfly flights, yet even in this alien environment, he had found order and pattern. Had seen the operation of natural laws that were comprehensible to human reason, had confirmed that the universe operated according to principles that could be discovered and understood through careful observation and systematic investigation. This realization, more than any specific discovery about minerals or transformative processes, seemed to him the expedition's most valuable result, the confirmation that nature was not fundamentally mysterious or capricious, but rather operated according to consistent rules, that these rules could be discerned through patient study, and that understanding them granted not power over nature, but rather the ability to work in harmony with natural processes. To achieve through knowledge and skill what could never be achieved through force or ignorance. After days of steady climbing and careful navigation, after countless passages and chambers that had become familiar through repeated traversal, after hours that blurred together in the unchanging darkness until time seemed to have lost meaning entirely, they finally saw ahead of them something that they had not seen for weeks, a faint grayness in the distance, not the yellow glow of lamplight, but rather the cool illumination of daylight penetrating into the cave system from the entrance far ahead. And the sight of that distant light brought a surge of emotion that surprised the practitioner with its intensity, for he had not realized how much the absence of natural light had affected him, how much the human spirit craved the sun's illumination, even when the mind was focused on other matters. They pressed forward with renewed energy, and gradually the light grew stronger, the grey becoming brighter, details of the passage ahead becoming visible not from their lamps but from the daylight streaming in, and finally they emerged from the cave's mouth into a world of overwhelming brightness, the afternoon sun shining with an intensity that made them shade their eyes and blink in discomfort, their vision adapted to lamplight needing time to adjust to the brilliance of the open sky. The surface world seemed both alien and familiar, for they had been gone only a matter of weeks, but those weeks spent in the mountain's depths had given them a different perspective, had made them see with new eyes the complexity and beauty of the living world, the endless variety of colors that existed under natural light compared to the monotones of lamplight and stone, the movement of leaves stirred by wind compared to the utter stillness of the deep caves. The sounds of birds and insects compared to the silence broken only by dripping water and their own voices. They rested near the cave entrance, letting their eyes adjust, feeling the warmth of sunlight on their faces, and the practitioner felt a sense of completion, of having successfully undertaken a difficult journey and returned with what he had sought, though he also felt that in some way the journey was not truly over, that the real work of analyzing and interpreting his observations still lay ahead, that understanding what the mountain had revealed would require as much effort as the expedition itself had demanded. Though that effort would be of a different kind, intellectual rather than physical, conducted in the familiar environment of his laboratory rather than in the mountain's alien depths. In the weeks and months that followed his return, the practitioner devoted himself to the detailed analysis of the specimens he had collected and the observations he had recorded, working in his laboratory with the same systematic methodology he had employed in the cave, subjecting materials to various tests and procedures, comparing samples from different locations and different depths, attempting to identify the specific elements and compounds present in each specimen, and to understand the relationships between chemical composition, physical properties, and the conditions under which each sample had formed. He confirmed his impression that the unusual minerals from the deepest chambers contained combinations of elements that rarely occurred together in surface deposits, and through careful analytical work, he was able to determine that these combinations reflected not any mystical or supernatural process, but rather the operation of natural chemical affinities under specific conditions of temperature, pressure, and chemical environment. Conditions that existed in the mountain's depths, but that could potentially be created artificially if one understood what those conditions were and how to maintain them. The water samples he had collected proved particularly informative, for chemical analysis revealed that the different springs and pools in the cave system contained different concentrations and combinations of dissolved minerals, and by comparing these compositions with the mineral deposits found near each water source, he could begin to understand the relationships between what was dissolved in the water and what precipitated out under various conditions. Developing a more sophisticated understanding of solubility and precipitation, of how substances moved from dissolved to solid form and vice versa, of the factors that determined which compounds would form when solutions mixed or when conditions changed. This work led him to develop improved methods for separating and purifying substances, techniques that moved beyond the sometimes crude procedures of traditional alchemy toward more precise and controlled methods, and these methodological improvements would prove valuable not just for his own research, but for the broader development of chemical science, for they represented steps toward the systematic analytical chemistry that would emerge in later centuries. Perhaps most significantly, his work with the specimens and his reflection on the observations made during the expedition led him to formulate more clearly the principles of transformation that had guided his thinking, but which he had previously understood only implicitly, and he began to write a treatise, not a mystical text full of allegory and coded language as many alchemical works were, but rather a straightforward account of his observations and the conclusions he had drawn from them, a work intended to communicate clearly and precisely what he had learned about the nature of material transformation, about the relationships between substances, about the importance of conditions and environment, about the fundamental unity underlying the apparent diversity of material forms. This treatise would not be widely circulated in his lifetime, for he remained cautious about attracting attention or making claims that might be misunderstood or misused, but it would survive him. Would be found among his papers after his death, and eventually copied and distributed among natural philosophers and early chemists who recognized its value as a bridge between the older alchemical tradition and the emerging scientific approach to understanding matter and its transformations. The story of the practitioner's expedition into the mountain and the insights he gained there represents more than just an individual achievement, more than the success of one person's quest for understanding, for it illustrates broader themes about the nature of scientific investigation and the development of human knowledge. The practitioner's approach combined theoretical understanding with empirical observation, using ideas and frameworks from the alchemical tradition to guide his investigation, but remaining open to what observation revealed, willing to modify or abandon theoretical expectations when they conflicted with what he actually found. And this balance between theory and observation, between what we expect to find and what we actually discover, is essential to scientific progress in any era. His recognition that controlled conditions were crucial for understanding natural processes anticipated the modern scientific emphasis on experimental design and reproducibility, the understanding that to truly comprehend how nature works, we must be able to isolate variables, to change one factor while holding others constant. To create situations where cause and effect relationships become clear rather than remaining obscured by the complexity of natural systems, where everything affects everything else simultaneously. The mountain itself in this narrative serves as more than just a setting, for it represents the natural world as laboratory, as teacher, as demonstration of principles that operate whether humans observe them or not, and the practitioner's decision to go into the mountain rather than remaining in his surface laboratory reflects a profound understanding that while controlled experiments are valuable, there is also tremendous insight to be gained from studying natural processes in their native environments. From observing how nature herself conducts experiments over geological timescales, producing results that no human laboratory could replicate because of the vast scales of time and energy involved. This approach of learning from nature, of studying natural systems to understand fundamental principles that can then be applied in artificial contexts, remains central to scientific methodology, visible in fields from materials science to medicine, from engineering to ecology, wherever researchers recognize that billions of years of natural processes have already explored vast realms of possibility, and that understanding what nature has discovered can guide human innovation and creation. The central question that drove the practitioner into the mountain, the question of transformation and how one substance becomes another, is in many ways the fundamental question of chemistry, the science that would eventually emerge from the alchemical tradition, and his investigations in the cave system led him toward understanding that transformation was not a simple or singular process, but rather involved multiple mechanisms operating at different scales. From the rearrangement of components too small to see to the large-scale changes in physical properties that resulted from those microscopic rearrangements. He understood that what appeared to be a single substance might actually be a mixture or compound of simpler components, that these components could be separated and recombined, that the properties of a substance depended not just on what components it contained, but on how those components were arranged and combined, and this understanding moved him toward a more sophisticated view of matter as composed of discrete units that could combine in various ways. An understanding that would eventually lead to modern atomic theory, though he himself lacked the conceptual framework to take that final step. The mineral deposits in the cave demonstrated transformation through crystallization and precipitation, processes where dissolved substances came out of solution and formed solid structures, and the practitioner recognized that these processes were reversible, that what had precipitated could be redissolved if conditions changed, that matter moved back and forth between different states depending on environmental factors like temperature and the presence of other substances. And this understanding of chemical equilibria, of reactions that could proceed in either direction depending on conditions, represented a significant advance over earlier ideas that saw chemical changes as irreversible, as one-way processes where substances were consumed and new substances created without any possibility of reversal. He saw in the cave's layered mineral deposits evidence that conditions had changed over time, that what precipitated at one period might dissolve during another period and then reprecipitate when conditions changed again. And this temporal dimension, this understanding that chemical systems had histories and that their current state reflected past conditions, added depth to his understanding of transformation as a dynamic process rather than a static phenomenon. The practitioner also grappled with the question of what drove transformation, what force or principle caused substances to combine or separate, to react or remain inert, and while he lacked the modern understanding of chemical bonding and molecular interactions, he developed an intuitive sense that substances had affinities for each other, that some materials naturally combined while others remained separate. That these affinities could be stronger or weaker and could be influenced by conditions like temperature and concentration. He noticed that certain metals would displace others from solutions, that some acids would dissolve specific minerals while leaving others untouched, that patterns existed in these behaviors suggesting underlying order and regularity, and he attempted to catalog these patterns, to create what we might now call a reactivity series, a ordering of substances according to their tendency to react or their ability to displace other substances in chemical reactions. This work, though crude by modern standards, represented an important step toward understanding chemical behavior as governed by consistent principles rather than as arbitrary or mystical. One of the most striking features of the practitioner's expedition was the way he used the cave system's vertical structure as an organizational framework for his investigation, recognizing that different depths represented different conditions, and therefore different types of mineral formation and transformation, and this vertical thinking. This understanding that the world is stratified, and that different levels operate according to different rules while still being connected by underlying principles, has broader applicability to how we organize and structure knowledge itself. In the cave, deeper meant older rock, higher temperatures and pressures, different chemical compositions and different mineral formations, and by systematically sampling and studying material from different depths, the practitioner was able to understand how changing conditions affected outcomes, how the same basic processes produced different results when parameters shifted. This approach of studying variations, of deliberately seeking out different conditions and comparing results, is fundamental to experimental science, and the practitioner's use of the mountain's natural variation as a kind of preset experimental array demonstrated sophisticated thinking about how to gain maximum insight from limited resources and opportunities. The vertical structure also served as a metaphor for the layers of understanding itself, for the practitioner recognized that surface observations, the phenomena easily accessible to casual investigation, represented only the most superficial level of comprehension, and that deeper understanding required descending into realms that were less accessible, more challenging to investigate, but potentially more informative about fundamental processes and principles. Just as the deepest chambers of the cave revealed mineral formations that demonstrated transformative processes most clearly, so the deepest investigations into natural phenomena revealed principles that were less apparent in surface observations, but more fundamental to understanding how nature truly worked. This recognition that there are levels of explanation, that we can describe phenomena at different depths of analysis, from superficial description to fundamental mechanism, and that deeper levels of explanation are generally more powerful and more broadly applicable, though also more difficult to achieve, represents sophisticated epistemological thinking and understanding of the structure of knowledge itself. The practitioner's journey into the mountain can thus be read as an allegory for the scientific enterprise more broadly, the descent into darkness representing the willingness to venture beyond familiar territory and comfortable certainties, to pursue understanding even when the path is difficult and the outcome uncertain, the various chambers and passages representing different domains of investigation, each with their own characteristics and challenges. The specimens collected representing data and observations, the return to the surface representing the synthesis and communication of findings, and the subsequent analysis representing the transformation of raw observation into structured understanding. This allegorical reading does not diminish the literal truth of the story, the real expedition into real caves to study real minerals, but rather enriches it, showing how specific investigations can exemplify broader patterns and principles, how individual stories of discovery connect to the larger narrative of human knowledge and its development over time. The practitioner's decision to undertake such a demanding and potentially dangerous expedition raises questions about the relationship between risk and knowledge, about what we are willing to sacrifice or endure in pursuit of understanding, and about how we balance the value of potential discoveries against the costs and dangers involved in seeking them. The physical risks of cave exploration were real and significant, the possibility of becoming lost in the maze of passages, of equipment failure leaving them stranded underground, of rockfalls or flooding, of injury in an environment where rescue would be extremely difficult. Yet the practitioner judged these risks acceptable given the potential value of what he might learn, and his assistants, presumably after being fully informed of the dangers, made the same judgment. This willingness to accept significant personal risk in pursuit of knowledge is a recurring theme in the history of science and exploration, visible in accounts of researchers who exposed themselves to diseases they were studying, who tested experimental devices on themselves, who traveled to remote and dangerous locations, who dedicated years of their lives to investigations that might ultimately prove fruitless. The question of what makes such risks acceptable or worthwhile is complex and probably has no single answer, for different individuals are motivated by different combinations of curiosity, ambition, altruism, and the simple desire to know what others do not know, to see what others have not seen, to understand what remains mysterious. For the practitioner in our story, the motivation seems to have been primarily intellectual, a genuine desire to understand transformation and material processes more deeply, to resolve questions that had troubled him throughout his career, to achieve a level of comprehension that would give his decades of study meaning and coherence, and this intellectual motivation, this pursuit of understanding for its own sake, rather than for any practical application or material benefit, is one of the purest forms of scientific motivation, though it is not the only legitimate one. The fact that his discoveries would eventually have practical applications would contribute to the development of analytical chemistry and metallurgy and other useful arts, validates the enterprise from a utilitarian perspective, but for the practitioner himself, the understanding was its own reward, the achievement of comprehension was itself the goal, and any practical applications that might flow from that understanding were secondary considerations. The story also illustrates the importance of preparation and methodology in transforming risk into productive investigation, for the practitioner did not simply rush into the mountain unprepared, but rather spent months planning his expedition, studying maps and reports, assembling appropriate equipment, training his assistants, developing systematic procedures for observation and specimen collection. And this careful preparation turned what could have been a reckless adventure into a disciplined scientific investigation, maximized the chances of success while minimizing unnecessary dangers, and ensured that the results of the expedition would have lasting value rather than being lost due to inadequate documentation or contaminated by poor methodology. This balance between boldness and caution, between the willingness to venture into unknown territory and the discipline to do so systematically and carefully, characterizes successful scientific investigation in any era, and the practitioner's example reminds us that advancing knowledge often requires not just intellectual brilliance, but also practical wisdom. Not just theoretical insight, but also methodological rigor. Beyond the transformation of materials that was the ostensible subject of the practitioner's investigation, there is another transformation at the heart of this story, the transformation of the practitioner himself, the change in his understanding and perspective that resulted from his weeks in the mountain's depths. He descended into the mountain as an alchemist, a practitioner of an ancient art with roots in mystical traditions and laden with symbolic and allegorical meanings, and he emerged still an alchemist in terms of his methods and his goals, but with an understanding that had shifted toward what we would now recognize as a more scientific approach, an emphasis on observation and measurement over theory and tradition. A willingness to let nature be the teacher, rather than insisting that nature conform to human expectations and theoretical frameworks. This transformation was not a rejection of his alchemical training, for that training had given him the conceptual tools and practical skills necessary to conduct his investigation, but rather a refinement and evolution, a movement toward greater precision and empiricism, while retaining the fundamental alchemical insight that matter is not fixed and immutable, but rather dynamic and transformable according to natural laws that can be discovered and applied. The practitioner's personal transformation also involved a shift in his relationship with the natural world, for spending weeks in an environment so utterly unlike the familiar surface world, so alien to human needs and human scales, had given him a different perspective on humanity's place in nature, a recognition of how vast and old the natural world is compared to human civilization, how much time and how many processes operate beyond human awareness or influence. How much we still have to learn about the world we inhabit. The mountain had existed for millions of years before humans evolved, would continue to exist for millions of years after humanity had passed away or evolved into something unrecognizable, and the processes he had observed operating in its depths were indifferent to human concerns, proceeding according to their own timescales and their own logic, without regard for whether anyone observed or understood them. This recognition of human transience and the vastness of natural time could be humbling or even depressing, yet the practitioner seems to have found it inspiring rather than discouraging, for it meant that there would always be more to discover, that the work of understanding nature could never be completed, that each generation of investigators could add to the accumulated knowledge, while still leaving vast realms of mystery for future explorers. His transformation was also practical and methodological, for the experience of conducting investigations under such challenging conditions, with limited resources and equipment, in an environment where everything was more difficult than in a comfortable surface laboratory, had forced him to think carefully about what was truly essential and what was merely convenient, about which observations were most informative and which procedures were most reliable. And this refined understanding of methodology would serve him well in his subsequent work, making him more efficient and effective in his investigations, better able to distinguish significant results from experimental artifacts or chance variations. The mountain had been a stern teacher, unforgiving of mistakes, demanding precision and care, and the practitioner had learned lessons that no book could teach, lessons that came only from direct experience of difficulty and challenge, from the necessity of getting things right the first time because there might not be an opportunity to repeat the work. If we step back and consider what the mountain taught the practitioner, what lessons emerged from his weeks in its depths, we can identify several themes that have broad applicability beyond the specific context of alchemical investigation. First and most fundamentally, the mountain taught patience, for the processes visible in the cave system operated over vast timescales, building mineral deposits layer by microscopic layer, carving passages through solid rock over millennia, working with such slowness that human impatience was not just irrelevant but absurd, and this lesson in patience, this recognition that some processes cannot be rushed. That understanding takes time, and that trying to force premature conclusions or shortcuts leads only to error and confusion, is crucial for any investigator of natural phenomena. The practitioner learned to observe without immediately judging, to collect data without rushing to interpretation, to let patterns emerge from accumulated observations rather than imposing preconceived patterns onto incomplete information, and this disciplined patience made his conclusions more reliable and his understanding more robust. Second, the mountain taught the value of systematic methodology, for in the darkness and complexity of the cave system, where everything looked similar and it was easy to become confused or disoriented, only careful procedures and meticulous record-keeping prevented chaos and ensured that observations could be meaningfully compared and interpreted. The practitioner's insistence on proper labeling of specimens, on accurate documentation of location and conditions, on systematic rather than random exploration, on organized storage and cataloging of collected materials, transformed what could have been a confusing jumble of impressions and samples into a structured body of data that could support reliable conclusions, and this lesson about the importance of method, about how systematic procedures amplify human cognitive abilities and allow us to deal with complexity that would otherwise overwhelm our limited memories and attention, a applies to any form of investigation, whether in natural science or in other domains of inquiry. Third, the mountain taught humility, for it revealed how much existed beyond the practitioner's previous knowledge and understanding, how his years of study had given him only a partial and incomplete picture of the phenomena he studied, how much remained to be discovered and understood. This humility is not the same as self-doubt or lack of confidence, for the practitioner retained confidence in his methods and his ability to discover truth through systematic investigation, but rather a recognition that individual understanding is always limited and partial, that we know much less than we might imagine we know, and that approaching nature with an attitude of openness and willingness to learn serves us better than approaching it with fixed ideas and inflexible theories. The mountain consistently surprised him, showed him phenomena he had not expected, demonstrated relationships he had not previously recognized, and each surprise was an opportunity to learn, to refine his understanding, to recognize that nature is always more complex and interesting than our theories about nature, and that theories must always bend to accommodate observations rather than observations being forced to fit theories. Fourth, the mountain taught integration, the recognition that phenomena are interconnected rather than isolated, that the mineral deposits depended on the water chemistry, which depended on the rock composition, which depended on the geological history, that everything affected everything else in complex webs of relationship and causation, and that understanding any particular phenomenon required understanding its context and connections. This holistic thinking, this recognition of interconnection and interdependence, stands in contrast to reductionist approaches that try to understand complex systems by breaking them into isolated components. And while both approaches have value and both have contributed to scientific progress, the practitioner's experience in the mountain emphasized the importance of seeing whole systems, of recognizing that the sum is often different from and more than the total of the parts. That properties can emerge from interactions that are not predictable from studying components in isolation. The story of the practitioner's expedition into the mountain, while specific to its time and context, echoes forward and backward through history, connecting to earlier traditions of knowledge-seeking and anticipating later developments in scientific understanding. Looking backward, we can see connections to earlier traditions of descending into caves for wisdom or revelation, traditions found across many cultures where caves served as places of transformation, where individuals went to seek knowledge or power or understanding that could not be found in the ordinary world of surface and daylight. And while the practitioner's expedition was motivated by natural philosophy rather than by spiritual or mystical goals, the underlying pattern remains similar. The journey into darkness in search of illumination, the descent into the underworld that precedes return and transformation. The universality of this pattern suggests something deep about human psychology and our relationship with knowledge. Perhaps recognition that genuine understanding often requires leaving familiar territory, venturing beyond what is comfortable and well known, facing challenges and difficulties, and emerging changed by the experience. Looking forward, we can see how the practitioner's work anticipated later developments in geology and chemistry, how his recognition that conditions affected outcomes would be formalized in concepts like reaction equilibria and phase diagrams, how his systematic study of mineral deposits contributed to the development of mineralogy as a scientific discipline, how his careful methodology exemplified the experimental approach that would become central to modern science. We can trace lines of influence, though they may be subtle and indirect, from his treatise on transformation to later works on chemical combination and decomposition, from his observations of crystallization to later studies of solid-state chemistry, from his use of the mountain as natural laboratory to later traditions of field study in geology and ecology, and while no single individual's work determines the course of scientific development, which proceeds through the contributions of many investigators building on each other's insights and correcting each other's errors, still individual stories like that of the practitioner illuminate the process, show us how understanding advances through the dedication of particular people working under specific conditions, and how their achievements become part of the collective enterprise of human knowledge-seeking. The story also resonates with contemporary concerns and questions about the relationship between humanity and the natural environment, for the practitioner's approach to the mountain was neither purely extractive, taking without regard for what was taken from, nor purely reverential, treating nature as sacred and untouchable, but rather something in between, an attitude of respect combined with curiosity, a willingness to disturb and investigate, but also to observe and learn. To take specimens, but also to document context and minimize damage, to enter nature's laboratory as a student rather than as a conqueror. This balanced attitude, this recognition that we can and should investigate and use the natural world while also respecting its integrity, and its value beyond mere usefulness to humanity, seems increasingly relevant in an age when human impacts on natural systems have become profound and global, when the question of how to relate to nature has become not just philosophical but urgent and practical, requiring answers that balance legitimate human needs and aspirations against the reality that we remain part of nature and dependent on its continued functioning. Among the specimens the practitioner brought back from his expedition, carefully preserved and labeled, one in particular came to symbolize for him the essential lessons he had learned in the mountain's depths, a small crystal formation from the deepest chamber, from the spring where mineral-laden water emerged from cracks in the ancient rock. The crystal itself was unremarkable in appearance, a geometric form perhaps the size of a fingernail, translucent with a slight grey tint, but what made it significant was what it represented, for this crystal had formed slowly over years or decades or perhaps centuries, each layer building on the previous, each layer recording the composition of the water at that particular moment, the temperature and pressure and chemical conditions that existed when that specific layer precipitated. And the entire structure thus constituted a kind of archive, a record written in matter itself of conditions and changes over time. The practitioner kept this crystal in his laboratory, where he could see it daily, and it served as a reminder of several truths he had learned in the mountain and which he wanted to keep central to his thinking. First, the crystal reminded him that understanding requires patience, and that truth reveals itself slowly, layer by layer, requiring sustained attention and systematic investigation rather than dramatic breakthroughs or sudden revelations. For just as the crystal had grown slowly through the accumulation of microscopic layers, so understanding grew slowly through the accumulation of careful observations and the gradual refinement of theories to accommodate new data. Second, the crystal reminded him that nature keeps records, that the past is not simply gone, but leaves traces that can be read by those who know how to interpret them, whether in the layers of a crystal or the strata of sedimentary rock or the rings of a tree, and that part of the natural philosopher's task is learning to read these natural records, to extract from them information about processes and conditions and changes over time. Third, the crystal reminded him of interconnection, for its formation had depended on processes operating at many scales, from the geological forces that created the mountain and its internal structure to the chemical properties of the elements, involved to the specific microconditions that determined exactly when and how each layer precipitated, and understanding even this small simple object required considering factors ranging from the microscopic to the geological. The crystal also served a more personal function, as a tangible connection to an experience that had been transformative for the practitioner, a reminder of weeks spent in absolute darkness, of physical challenge and intellectual excitement, of the satisfaction of pursuing a question to its source and finding not a simple answer, but a deeper understanding that generated new questions even as it resolved old ones. Objects can carry meaning beyond their physical properties, can become invested with memories and associations that make them valuable in ways that have nothing to do with their monetary worth or practical utility. And for the practitioner, this crystal was such an object, precious not because it was rare or beautiful, but because it connected him to a journey that had changed his understanding of his work and his relationship to the natural world. He would occasionally take it out and hold it, feeling its smooth faces and sharp edges, looking through its translucent structure at the lamplight beyond, and in those moments he would remember the mountain's depths, the pools and passages and chambers, the gradual accumulation of observations that had led to understanding, and he would renew his commitment to the work of investigation, to the patient, systematic pursuit of knowledge about the natural world and the transformative processes that operated within it. The practitioner continued his alchemical investigations for many more years after returning from the mountain, applying the insights he had gained to his laboratory work, refining his techniques, conducting new experiments, corresponding with other natural philosophers, and sharing observations and ideas, contributing in his modest way to the slow collective advance of human understanding of material processes and chemical transformation. He never returned to the mountain, for he felt that he had learned what it had to teach him, that returning would be repetitive rather than revealing, and he was content to work with the specimens and observations he had brought back, which provided material for analysis and reflection for the remainder of his career. His treatise on transformation, written in the years immediately following the expedition, circulated in manuscript among a small group of serious investigators, and while it did not achieve widespread fame or recognition during his lifetime, it was preserved and copied and eventually printed, becoming recognized as an important transitional work between alchemical and chemical thinking. Valued both for its specific observations and methodological innovations, and for its articulation of principles that would be further developed by later generations of chemists. The practitioner's story, like many stories of scientific investigation, is one of dedicated individuals pursuing understanding through careful work, facing challenges and overcoming obstacles, experiencing setbacks and making progress, and ultimately contributing to the gradual accumulation of knowledge that characterizes human intellectual history. And while dramatic breakthroughs and revolutionary discoveries capture public imagination and historical attention, the reality is that most scientific progress happens through exactly this kind of sustained careful work, through expeditions like the one into the mountain, through systematic observation and meticulous analysis, through the patience to pursue questions over years or decades, through the discipline to maintain rigorous standards even when working alone or in obscurity, through the commitment to truth and understanding even when the path is difficult and the rewards uncertain. The practitioner exemplifies these qualities, and his story honors not just his individual achievement but the countless other investigators, known and unknown, celebrated and forgotten, who have pursued knowledge with similar dedication and whose collective efforts have built the edifice of human understanding. As we conclude this account, it is worth reflecting on what such stories offer us beyond their immediate narrative interest, for they serve multiple functions, as history recording what actually occurred, as illustration demonstrating general principles through specific examples, as inspiration showing what is possible through dedication and systematic effort, and as connection linking us to those who came before and reminding us that we too are part of the ongoing human project of understanding the world we inhabit. The practitioner's descent into the mountain and his discoveries there occurred in a specific time and place, involved particular people and particular circumstances that can never be exactly duplicated. Yet the essential pattern, the pattern of question leading to investigation, leading to understanding, leading to new questions, is timeless and universal, as relevant to investigators today as it was in the practitioner's era. As applicable to contemporary questions about the nature of matter and energy and the fundamental constituents of the universe, as it was to questions about the transformation of base metals and the formation of minerals in deep caves. The mountain itself endures, as mountains do, indifferent to human concerns and human timescales, its caves and passages continuing to exist in darkness, its mineral deposits continuing to form layer by microscopic layer, its springs still seeping from cracks in ancient rock, and if the specific chambers the practitioner investigated could be relocated and revisited, we would likely find them largely unchanged. For the processes operating their work so slowly that decades or even centuries make little difference, and this permanence provides a kind of comfort, a reminder that nature's laboratory continues to operate, that the experiments that taught the practitioner his lessons are ongoing, that future investigators can return to the mountain or to similar places and make their own observations, test their own hypotheses, learn their own lessons from what nature has to teach. Knowledge is not static but constantly evolving, each generation adding to what previous generations discovered, correcting errors and refining understanding, asking new questions that earlier investigators could not have imagined, using new tools and methods that extend our observational and analytical capabilities. Yet the fundamental enterprise remains the same, the attempt to understand the natural world through careful observation and systematic investigation. And in this enterprise, we are all connected to investigators like the practitioner, all part of the same long conversation about the nature of reality and how we come to know what we know. The story of the alchemist's tale under the mountain thus offers us not just an account of one person's investigation and discoveries, but a meditation on the nature of inquiry itself, on what it means to seek understanding, on the relationship between humanity and the natural world, on the patient accumulation of knowledge through systematic effort, on the transformation not just of materials but of understanding, and on the enduring human desire to know, to comprehend, to grasp the principles that govern the world we inhabit. And these themes transcend the specific historical context of alchemy and mineral formation to speak to universal aspects of the human experience, to our curiosity and our persistence, to our capacity for careful observation and systematic thinking, to our ability to learn from nature and from each other, and to the satisfaction that comes from pursuing questions to their sources and emerging with understanding that, while never complete or final, represents genuine progress in the long project of comprehending the intricate and beautiful world in which we find ourselves. A world that rewards investigation with insight, patience with understanding, and dedication with the deep satisfaction of knowing that one has contributed, however modestly, to the collective human enterprise of making sense of existence. And with this understanding, our story concludes, the alchemist's tale complete. The mountain still standing in silence, keeping its secrets while also revealing them to those willing to descend into darkness in search of illumination. A fitting end to an account that began with descent and concludes with understanding, that started with questions and ends with insights, that moved from surface to depths and back again, transformed by the journey and the discoveries made along the way. And now preserved in words, so that others may know what was learned, and perhaps be inspired to undertake their own journeys into unknown territories, to ask their own questions and pursue their own understanding, continuing the work that the practitioner began and that continues still in laboratories and field sites around our world. The eternal human quest to understand the nature of matter and energy, of transformation and permanence, of the processes that shape our world and our existence within it.